All right, in the next few lectures, what we're going to be doing is taking a look at a system or systems that combine a lot of the aspects of heat transfer that we've been looking at thus far in the course. And the topic that we're going to look at are heat exchangers. And heat exchangers are very interesting. There are many, many different types that exist, but essentially what we're doing is we're transferring energy, thermal energy, from one fluid to another fluid. So that is the way to describe what a heat exchanger is and does. Essentially what it does, it transfers energy, remember I said thermal energy, between two fluids at different temperatures, and we need to keep the two fluids apart, and consequently they're separated by a solid wall. Now, heat exchangers are used all over the place. We use them in many, many, many different types of engineering systems. And so let's take a look at a few different types of heat exchangers. But before we get there, applications of heat exchangers could consist of the following. And this is just a very limited subset. So power production, that would be anything from a Rankine power plant to internal combustion engine, even a Stirling engine, any of those cycles. It also is used in space heating. So heating of buildings or homes, and air conditioning. So cooling of spaces. It's used for refrigeration. And another example, chemical processing. So we use heat exchangers in many, many different engineering applications. And what we're going to do now, we're going to take a look at some of those applications, and we'll also take a look at a couple of different designs of heat exchangers as we go through and look at these next set of images and videos. So what we're going to do, we're going to begin with transportation and automotive transportation. And this is an old car from 1893. It's a quadricycle by Peugeot, and it was one of the very early gasoline-powered automobiles. But you can see there's a heat exchanger behind the wheel. And when you zoom in closer, that's another view of the heat exchanger by the front wheel of this Peugeot automobile. This is the Vis-a-Vis. It is another car. It was produced in France by Dion and Bouton, but when you look at the front of it, you can see something that looks like a heat exchanger, and sure enough, that is a very, very early radiator, similar to what we saw on the Peugeot. And there are the fins on the radiator. They're a little bent with time, but this is from 1899, and this speedy looking vehicle, this is a Ford Model T, and you can see the heat exchanger on the front. Ford, in a period of 20 years, starting in 1908, sold 15 million of these. And so automobiles were all over. And as you can see, today we do have automobiles everywhere. And this is rush hour, early morning. If you look at the front of the vehicles, you'll see kind of a lighter temperature that signifies heat. That one doesn't have a lot of heat in it, but there are some that do, and that would be the location of the radiator that we have in the vehicles. So anyways, you can see the progression and the use of heat exchangers in power production of automobile applications, because any power cycle, we always have to reject some of the thermal energy, and we often do that with the heat exchanger. Now, moving on, I talked about air conditioning and refrigeration, so let's take a look at those applications. And here we can see a refrigerator. This is one that has the compressor and the heat exchanger in the bottom. You can see the IR camera. There's a fan circulating air. So that's a fluid to air heat exchanger. If you've ever stayed in a hotel, I'm sure you've heard this all night long. This is a heat pump, either heating or for cooling inside of a hotel room, and it'll cycle in and out throughout the night. There are heat exchangers within there to cool the air that is going through that. This is a larger type of heat exchanger used for refrigeration or cooling applications, air conditioning, and you can see the heat exchangers are at an angle. This is a view of Tokyo. And if you look down any large city, you'll find heat exchangers. These are the cooling systems used for rejecting the heat from the air conditioning for large buildings. And so that would be industrial applications that we have of both refrigeration as well as air conditioning. Now what we're going to do, we're going to go into industrial applications, and we're going to begin with the aerial coolers. And so the aerial coolers are, you have air on one side, and you could have a processed fluid or something else on the other. Could be a gas, but the aerial cooling units begin with tubes, and there we can see the tubes lying ready to have fins placed on them. This is what fins look like before they're put on the tubes. They come in big rolls. They're unrolled, and there you can see the fin coming out, and it is fed into a machine. You can see the tube spinning in the foreground there, and there's the tube spinning. The fin comes in, and then it is wrapped around the tube. And so that's the process of putting fins on tubes. And there you can see that the tube coming out that has the fins on it. And then after doing this with many different tubes, you get things that look like this. And there you can see the fins on the tubes and then a big stack. And these would all be used, and eventually they would go into the aerial cooling units. And so that is what the thin tube looks like. And those ultimately get attached to header boxes. And so here we can see a procedure whereby the tubes are being welded to the header box on the inside. And so this is a special welder that can go in and do a circular weld on the tube inside of the header box. And a very skilled practice in order to do that welding, as you can see this welder performing the practice there. And sometimes the tubes are expanded. And so here we have a tube expander, pneumatic driven, and each of the tubes inside of the header box is expanded, and that's the way that it is connected. And so for the aerial cooling units, we attach the tubes with the fins to the header box, and then this is what it looks like after. And here's an image of it being pressure tested to ensure everything is up to quality specifications. This is where it eventually goes. These are the fans that will circulate the air over the heat exchanger. You put it all together, you put it on a truck, and you transport it to the field. And so here you can see aerial cooling units being assembled. And they could be high, they could be anywhere within where the chemical engineers put them, and the mechanical engineers have to deal with it. And then this is an aerial cooling unit at a compressor station, and again you can see all of the different units like we saw being fabricated. So that is petrochemical applications or chemical processing where we have aerial cooling units. Now, another form of heat exchanger that we're going to look at in the next few lectures is the shell and tube heat exchangers. So let's begin by looking at that. So here we have a model of a shell and tube heat exchanger. You can see the baffles in the front. And so the baffles are what the tubes are going through. And then at the end there are tube sheets. So there is the tube sheet and there is a baffle. The baffles are partially cut for the fluid to go around that is within the shell. And there you can see all the tubes together with the baffles and the tube sheet at the end. You can see again there, that's a side view of the baffles, and then that's an end view of the tube sheet with all of the tubes coming out. And then when they're done, that's what it looks like. So that is a shell and tube heat exchanger when it is completed. Now, there have been some technology innovations that have come along over time with shell and tube heat exchangers, and we'll take a look at a couple of those. The first one has to do with a spiral baffle. And so here we can see the baffles are, they're spiraled or helical. And what that does is it causes the fluid to flow around it. It would reduce the pressure drop, and it would probably reduce fouling and increase heat transfer as well. And so that is a spiral baffle that we're looking at in this image. And there we can see a closer in view of the spiral baffle. And this is M baffle, where it's a longitudinal, basically a double pipe heat exchanger. And these baffles, essentially what they do, they create a lot of turbulence and enhance mixing, again reducing fouling. So those are some of the different types of heat exchangers that we're going to be looking at. It gives you an idea in terms of where heat exchangers are used. They're used all over the place, and so consequently that's why heat exchangers are such a very important topic in a course on heat transfer. And the thing that's nice about it is that heat exchangers combine everything that we've been looking at thus far in this course. They combine conduction across the wall, we have convection, you can have condensation, you can have boiling, you can have everything going on within heat exchangers. And so they really do represent a neat synthesis of everything that we have learned thus far in the course. So we're going to be looking at heat exchangers in the next few lectures, and that will guide us through what we're going to be taking a look at. We'll look at heat exchangers.